Hello, everyone. Welcome to TAF. I'm Jie, assistant professor in the Web Information System group at the TU Delft. So nice to see you and welcome. Today, we have the final talk for this speaker series. Before I introduce the talk, let me give a brief recap about the topic. So in this speaker series, we look at human-centered AI, which studies the design, development, but also the use and governance of AI systems for supporting human activities in a trustworthy manner. In this big series, we focus on the knowledge and language aspects, which are key concerns in making AI systems and humans understand each other and acting upon such an understanding through interaction. Now, on these topics, we have invited a list of speakers whose work has made a foundational contribution to these fields. This week, as I said, is the last week of the TAF series, and I'm thrilled to introduce our speaker, Philippe Cudré-Mauroux, full professor at the University of Freiburg in Switzerland, and a council member at the Swiss National Science Foundation, responsible for applied computer science. He received his PhD from EPFL, where he won both the doctorate award and the EPL Press mention in 2007. Before joining University of Freiburg, he worked on information management infrastructure at IBM Watson, Microsoft Research Asia and Silicon Valley, and MIT. He recently won the Verizon Internet Infrastructure Award, a Swiss National Center in Research Award, a Google Faculty Award, as well as a €2 million grant from the European Research Council. His research interests are in the next generation big data management infrastructures for non-relational data and AI. Today, Philippe will introduce his work on information monitoring, including TaxoComplete and other recent projects. Now, to all the participants, please feel free to ask questions during the presentation, but please use the chat. After the presentation, you can unmute yourself for questions. Now, without further ado, let's welcome Professor Philippe Cudré-Mauroux. Thanks again, Philippe, for being here. The floor is yours.
Thanks a lot, Jay. Yeah, I don't have much to add. Pleasure to be here. I hope I can see the chat. Let me check. I'm not sure I can see the chat. So if there is any urgent question through the chat, Jay, please let me know, right? I might not be able to follow otherwise. Happy to answer, urgent questions during the talk, and obviously questions after the talk. So let's delve into it. A bit of context. I'm a professor in Fribourg, Switzerland. You might not know Fribourg. If you see my mouse, it's here. It's between the French and the German part of Switzerland. In Switzerland, we have several languages, as you might know. French in the west, Swiss German in the east, Italian in the south, and also Romanche, right, in the very east. So Fribourg is a university kind of, we say in the middle of Switzerland because it's in between the French and the German parts. This is an old pre-COVID image of the group, and you can see that the image is old because we still had the pleasure to have Jay with us, right? But now, unfortunately, he left. But that's a different story. Please come and visit us, right? If you are next to Switzerland or in Switzerland, we are always very happy to have visitors. We have also, invited speakers series in terms of all kinds of departmental talks. So, we are very happy to host you. Oh, Ines is joining, which is great. That's the website of our group. It's not super updated, unfortunately, but I will try to update it the best I can. And that's basically the funding agencies which support our research. By the way, Switzerland is not part of the EU framework program, as I was describing to Jay just before. So unfortunately, no more ERCs, but I hope we can join again in a few years. It's kind of funny, right? Because Switzerland is in the middle of Europe, but we are not part of the EU, as you know, for strange political reasons. Anyway, let's not talk about politics. Today, I will tell you a bit about information monitoring. right? So I will describe a bunch of projects we had recently in my lab, some a bit older, some very new. And it will all be about monitoring what's happening using, like it's this image, right? Using all kinds of dashboards and automated processes. So a bit of context, monitoring is obviously key in most large companies, right? In Switzerland, same as in the Netherlands, we have a bunch of very big companies from Nestle to Google to the banks and insurance companies. And all those companies, they are crazy about monitoring, right? This is for them, this is crucial, mostly in terms of reaction, right? They want to know what's happening. They want to monitor what's happening because they want to react earlier than competitors. That's why this kind of monitoring is super important. Today, I will tell you a bit about two kinds of monitoring. The first is event monitoring. Right, so I will tell you a bit what we build in terms of tweets and how we can monitor tweets automatically, and how we can also monitor things in the cloud. And then, so this is basically streaming, right? This is like, we want to know in real time what's happening, basically, or at least have a streaming view of the monitoring, you know, like artifacts, and then be able to also do postmortems and analytics. Very important. Second topic is related. It's more like, you know, monitoring what's happening in terms of other people doing things in your field, right? So for us, it's a lot of technology monitoring. It means being able to understand who does what in terms of R&D or products, and to be able to react, right? So today, it's obviously super important in terms of generative AI, but you can imagine that it's always the case. You always need to know what your competitors or what the landscape basically is doing in terms of you know, technologies. And we've been developing this, both event monitoring and technology monitoring, quite a bit with those people here called Arma Suisse. Arma Suisse is a bit like DARPA in the US. And I suppose you have the same in the Netherlands. I don't know how this is named, but it's basically, you know, it's not the military, right? But it's a research organization which helps the Confederation, the Swiss Confederation. And they are very much interested in understanding what are the big events that are occurring right now, again, in terms of giving a response to those potential events, or understanding how Switzerland and other countries relate in terms of technology. So for them, it's very important. By the way, we don't do anything secret with them. Everything that we do is published. Most of it is open source. So, you know, nothing in terms of like weird business here. And in addition to Arma Suisse, we also worked on this with Microsoft. This will be the second project, like monitoring in the cloud. Okay, so let me delve into this. I will give you an overview of those four projects, and you'll see that they are all related. And as Jay explained before, this series is about, I think, knowledge and people, right, humans. And you will see that we have those two elements as core components of our approaches. So let's start with more like knowledge and real-time event detection. So this is something that we have worked on in my lab for a bunch of years, actually. It's obviously a very hard problem. The idea is to basically mine Twitter or other, you know, social media platforms in real time. And again, the motivation and basically the queries all came from this Arma Suisse R&D lab in Switzerland, because they are trying to do this to, again, then inform the political or the admin in Switzerland to issue an answer, to issue like an official statement regarding any given activities. One of the use cases they always give us in this context is plane hijacking. So they want to know if a plane is being hijacked. That's the one here, right? Because then they have to give, again, like a public kind of response, like, or what are they doing in terms of, you know, this plane being hijacked and potential Swiss citizen on this plane. But it's the same also as another query they have all the time is election in a given country, right? Like they might be interested in election in Asian countries. Why? Because again, then Switzerland has to, as early as possible, it has to give a statement, right, about the outcome of the election, whether, you know, everything was fine, whether, you know, it's a great outcome, what Switzerland basically thinks about it. And guess what? Before asking us to work on this problem, they were using keyword search in terms of, you know, finding the right tweets to match basically those queries. And as you can understand, this is not working, right, with a simple IR, I would argue, because election in Asian country and the particular tweets which will tweet about the election in a particular Asian country, they have zero similarity, right, in terms of keywords, but even if you add a bit of semantics, right, those are so broad categories that it's very difficult to basically match an instance with the broad query. And you add to this the fact that the tweets are very short, very informal, full of abbreviations, full of acronyms, and it's basically very difficult for them. It was very difficult for them to have any kind of automatic monitoring system for this, right? They had too many basically false positives, right? Also, I guess false negatives, by the way, because of this semantic mismatch. So first idea here in this talk, and first component in this task series, let's try to have a bit of knowledge to help the task, right? So what we want to do is basically analyze tweets, but we want to resort to additional knowledge, third-party knowledge, to have additional information on those tweets. And here comes our solution, ArmaTweet. And so we published this a few years ago. This was, by the way, collaboration with Oxford, Arma Swiss, and us, I think. And the idea is pretty simple, right? If you think about it, it's basically, you have a bunch of tweets. You have actually, at the time, many tweets coming from the fire hose. You could have like, you know, hundreds of tweets per second. We would parse a bit, obviously, those tweets, generate not triples, but some extended triples based on those tweets. And then that's the kind of magic, right? We would have a knowledge graph and we would basically match part of the tweet onto the knowledge graph. And we would also match the query onto the knowledge graph, such that then we can create positive results, like, it seems that a plane is being hijacked. So this would be like a positive result as an output. And then we analyze the time series of those positive results. We aggregate them. And if we have a peak of positive results, then we issue a warning to a human analyst and say, hey, it seems that according to all those tweets, you know, there is an issue which matches one of your queries. Okay, and then the human looks at the tweets and answers potentially to this threat or to this new event happening. So here's an example, like, to give you some concrete idea of how this would work. Here is a tweet. Edward Brooke, first Black senator since Reconstruction, dies at 95. Hashtag Birmingham and some URI. Okay. The query in that case, so the event we are interested in, I think, is politician dying. Okay. So the idea is we take this string of text and we will match it. We will basically align it with a bunch of additional resources that we have. In our case, we used DBpedia. You might remember DBpedia. It's basically a Wikipedia in triples. Now we probably use Wikidata, by the way, right? But at the time we used DBpedia, which was good enough. And we used WordNet for the verbs. Like, you know, if you say politician dying, obviously you want to have all kinds of basically synonyms for dying, right? So WordNet gives you this, like passing away, etc., etc. So basically, if you have this suite, and if you have a bit of matching, can be machine learning, can be, you know, subscreen matching, you have like zillions of papers doing the matching, then you can obviously fairly easily map Edward Brooke to its DBpedia entry, right? You can also probably map Birmingham, and you can map die to some kind of passing away / semantic, kind of higher level semantic token, right? You could also do this with embeddings, large language models, obviously these days. So this is basically the results, right? You go from this suite to a graph representation of this suite. What's the added value? It's that if you have a graph representation of this suite and you map it to different constructs from those large language models, or sorry, large knowledge graphs, you can infer quite a bit of things. For example, you can understand that Edward Brooke is here. Actually, he is a politician, right? So you automatically know by this matching that Edward Brooke is a politician. And from the query, you know that also that you are interested in this type. This is a specific type, Diago politician, right? So this is half the work already, right? If you can match Edward Brooke with the node in the knowledge graph and then follow the edges such that you know it's a politician, you have answered kind of half of the query. But you know more here. You know, for example, that Birmingham is the location, and then you can know that it's, you know, in the United Kingdom, which is a country. So you can also have very fine-grained localization, right, of all those results. And in that case, since the query is politician and dying, right, and this tweet can be matched to something which is a politician and it seems that the poor person has passed away, so we can directly issue this in the time series as a positive result and say, oh, it seems that there is a tweet here who tweets right now about one politician. By the way, in the UK, we can be very granular here, and this person is passing away, right? So we can basically have this as a result. Does this work? Of course, it works great compared to, I would argue, like, you know, even like pretty modern information retrieval, because we are tapping into a very big knowledge graph, DBpedia in that case, but also like WordNet. So we have tons of additional information, basically, which can expand the context of those very small tweets. So we got like almost 10x improvement in terms of precision recall, because basically we tap into this additional knowledge. And so this was a big win for our Swiss, basically. I hope this makes sense. Let me follow up with the same idea, but applied to something extremely different, right? I really like this second project because it's really the same, but for something totally different you might not have thought of. It's cloud infrastructures. So we worked on this with Microsoft, actually. So here is a bit the idea. Microsoft, they also have tons of automated real-time streaming text coming out of their infrastructure, but this is not tweets, this is logs. Because as you know, Microsoft has one of the biggest clouds in all the industry, right? Actually, it's #2 after AWS, Azure. It's #1 in Switzerland, by the way. So for us, Microsoft Azure is very important. And Microsoft Azure, each cloud, each sub-cloud, right? They have tens of thousands of machines, and each machine has a whole stack of programs, softwares, OS, virtualization that they are using, right? So they have like typically, a bunch of they have OS, a bunch of virtualization, then they have big data software. So it's really like probably 20 different software PCs running on each machine and doing some processing for the cloud. Okay, so this creates basically tons and tons and tons of log data. Because each of those programs, let's say Hadoop, if you remember Hadoop, or more like Cosmos for Microsoft. So Cosmos is kind of their Hadoop-like infrastructure. So each machine runs several Cosmos layers, and basically they output log data, which can be binary or can be text, like, oh, I did this operation at 4:23 p.m. In this particular data center working on that kind of data. This creates actually petabytes of logs daily. And how do they work with those logs? It was fairly manual before we changed the state of the art, right? Basically, what they do is they store all the logs on a large scale, file system, you can imagine. They pre-process some of the logs. They call this, cooked logs, and then engineers, people debugging stuff, people auditing also the system, they would write ad hoc analytical queries, right? Think MapReduce kind of queries to debug, to try to understand what happened exactly at 4:20 p.m. on this specific cluster in Azure. They would wait like 30 minutes because it's a lot of data shuffling, data parsing, data alignments, and then they would get a bit of results in terms of the output of the job, and then they would iterate, right? So it's basically data science in its purest form, meaning you launch scripts and you launch analytics and you iterate over and over to understand what's happening. So we thought we would do this very differently, and we would look also at this kind of monitoring system using exactly the same idea as for ARMA tweets, but totally different in terms of technical context. We would take the logs and parse those logs and create knowledge out of those logs at a higher level layer, right? So we would basically create a knowledge graph out of those logs. So I had one of my students, Ruslan, working at this for some time at Microsoft. The idea was to write parsers, both for textual logs and binary logs, to understand, same as the tweets, right? To understand all the instances which are important for us. But it's not a politician in that case. It's, a job, a server, a disk, a customer, so a process, right? And to basically rewrite all of those logs which are written at different levels, to rewrite them as a beautiful knowledge graph, right? So you have petabytes of daily logs on Azure. We represent this as a knowledge graph. And then the big advantage is that the users, Microsoft engineers, they can query this graph basically in real time. Because even though this graph is very, very big, like terabyte big, it's still much, much smaller than the petabytes and more of the logs. So that's the infrastructure that we had at the time. Now it has changed because they have productized this. So this is running on like hundreds of thousands of machines, right? But when we had this as a research prototype, we will have all the raw data being extracted. We would have a schema for our knowledge graph, and we would create then this graph. And by the way, that's interesting. At the time, we would already store it in 2 different databases because the graph was too big and too difficult to manage by one database. So we would do some of the real-time or analytical queries in Scope Cosmos and some of the simpler graph queries in a Neo4j kind of installation. And again, the cool stuff about this particular use case is that they productized it, right? So they are using this for auditing and compliance, GDPR typically, to be able to understand, to show, to demonstrate what happened to the different pieces of data, right? You simply look at the graph. But actually, once you have this monitoring, graph on top of your infrastructure, you can power a bunch of very cool applications. You can do job scheduling, like if I have to, deploy this very big job, where and when should I deploy it, basically? You can do global job ranking. Sometimes they have to cancel user queries, right? So they can basically understand which job will have the smallest impact by looking at the graph. Okay, this job is, modifying those data, hence we can basically stop it. It's not going to have too much of an impact on other jobs. But they have all kinds of crazy problems, right? Like, I didn't even know it was a problem. But for example, they are thinking in terms of data centers. They have lots of data centers, lots of clusters, right? Each with tens and thousands of machines. And then sometimes you have to move users from one cluster to the other, right? And this is a huge headache because, to understand what a user does, basically, and if a user could fit in a different data center. So if you have a graph perspective on this, you can understand, oh, this is kind of, a pretty single user, which is not connected to too many users. And I can move this user perhaps to another few users. I can move them together to a different data center. So again, I think fairly different use case. Think about it, but lots of potential improvement in that space, right? In terms of understanding what the cloud is doing on a large scale. Okay, let me switch now to the last two use cases. And those last two use cases were actually led by Ines. I see that she has joined the conversation. So hopefully she can tell me if I'm doing, if I'm not basically discussing this work accurately enough. I hope I will do a reasonable job. Let me see the chat. Very interesting. Okay. Oh, there is a question. Are tweets also represented as graph before matching? So the tweets are represented as graph. Yeah. So if I come back to the tweet example, where are my tweets? So this is basically the representation of the tweet, right? This is the string representation, and then this is the graph representation of the tweet. Again, I think the cool thing to understand here is that it's not only a graph representation of the tweet, but it's a graph representation linking to those different knowledge bases, right? Like DBpedia and WordNet. So that's why it's so powerful, because then you have additional information. Happy to talk about this later also. So let me go back now to technology monitoring, right? That's the second use case that ArmaSuisse gave us. So they want to know what's happening in terms of technology R&D in Switzerland. Okay, so they are building this platform called Technology Monitoring Platform. And they are building this for real, by the way. They have hired a few engineers, and they had some prototypes in the past, and now they're doing kind of the real software. So I hope that it will be somewhat open source and that we can use it. All the big companies I've talked to, they want this, right? And most of the big companies, by the way, they have already a version of this, obviously, right? Because for all big companies, as I was explaining before, it's important to understand what's happening in terms of technology for two reasons. It's important to know what are the hot topics, also what your competitors are doing, right? Obviously, you want to know this, but also for answering things, right? They want to understand what's the landscape in terms also of potentially answering to the customers, right? Like, oh, we are working on that. Oh, we are aware of this. This is very important for PR. It's very important for R&D, marketing, and PR. So to come back to our main customer, ArmaSuisse, they are interested in classifying web pages, which are mostly Swiss companies, into specific technologies, right? Like fairly specific technologies. They want to know who in Switzerland works on LED, visualization, whatever technologies, or if we are closer to ours, perhaps some, what can I tell you, some specific deep learning technologies, right? They want to know specifically what's happening. Or here I put this example, right? They want to know if a company in Switzerland is working on display technologies or LED displays or stage lighting instruments, which are all like fine-grained classes I tried to come up with. We're not talking about coarse-grained here taxonomies, right? But like a fairly fine-grained taxonomies to basically understand what's the R&D landscape in Switzerland. So this is basically a text classification problem, right? So this should be fairly easy in terms of tools. You take the text, potentially also the images, but for us we put the text only. You take the text of the page, basically describing what the company is doing, and you classify this into potentially hundreds of thousands of classes. Okay, but two things. First, this is a very vertical domain, right? This is not a usual text classification. This is text classification on a fairly niche, I would argue, domain. It's really like, they want to focus on technology only, right? They are not interested in anything else. Second issue is that, as you know, classification is mostly deep learning these days. Perhaps pre-trained model, I don't know. It's basically a black box, right? You have some web pages, you have a deep learning system, and then you have basically the outcome. And this is not good enough for many customers. This is not good enough for Arma Suisse, as you can imagine. This is an administration. It's close to the defense department. So if they make a decision, those people want to know why, right? And I think it's the case for many companies in Switzerland, like bank, insurance companies, even like Nestle, one of the biggest health and food companies in the world. Very often, if you give them a deep learning solution, they will say, but I need to know why I'm making this decision, because otherwise, I can get into trouble, because my business, they're not doing with like web ads or whatever, like instance classification, where if you make a mistake, it's no big deal, right? If you think in terms of health, in terms of defense, in terms of insurance or banks, if you make a mistake, this can have consequences, right? So they want to have some rationale to basically explain why the system made this or that decision. So basically, and here comes the second part of this, I guess, TAF series in terms of more like humans. Here comes the second part. We wanted to have some human readable justification, a rationale for the classification results. And you might think, but we have an attention mechanism, right? So that should be good enough, because if you can point out on the part of the input which was used most heavily for the decision, then that's good enough. Well, not quite, right? Because studies have shown that actually attention distribution is inconsistent with the input units, and two different attention distributions can yield the same result, right? So the idea of this, and obviously GA helped us for this, was to use crowdsourcing. Right? We thought, why don't we try to get additional rationale in the sense of having human rationale using crowdsourcing, and try to incorporate this into the framework to have a better explanation for the new cases, obviously, right? In terms of inference. So that's exactly what we did, right? But I guess all of you are aware that crowdsourcing, it's always more complex than it looks, in the sense that we always have this issue of truth inference, right? You have a bunch of input from different workers. Some are great, some are less great. Some do it fast, some do it slow. In the end, you have to integrate the results because you have different results. So the rationale provided by the crowd workers can guide the learning of the attention distribution. But, they can be different, as I tried to picture here, to illustrate here. They are not the same. Hopefully, they are a bit overlapping, right? But still, you might have some workers who do a very bad job at giving an explanation, right? Like here, the task is, highlight the part of the text, the sentence where, basically it tells you about this particular piece of text belonging to this particular category. That was the the task. And we introduced Marta for this. This was published at AAAI 2 years ago. So Marta is basically a Bayesian framework which uses these human annotations to basically derive better classification using human rationales for the classification. Right? And oops, and that's a bit how it works. So this is mostly, variational inference framework. Ines derived actually the efficient inference rules for this framework. So the parameters are learned efficiently through this EM step, right? This is the usual cycle when you do variational inference. So here is how it works. You have the processing platform, which collects the labels from the supervised cases by the crowd, right? So the crowds highlight the important sentences in terms of the classification. Then in the E step, incrementally, you will compute if the workers are more or less great, right? That's an approximation of basically how good a worker is at this job, right? It's basically the confidence you have in the worker. Right? The sentence importance, and the document classification, right? And then you update this in the M step, which is, this is integrated in the sentence level annotation model, which is used, to basically do the classification. So you learn the parameters through this cycle of EM step, and then you can use the results, the model with the right parameters that you have inferred for the classification of new documents. And this is a bit how it works. There is a question, I think, about the evaluation. Perhaps Ines can answer this question at the end of the talk if Ines stays for a bit longer. But basically, yes, we used two different kinds of state-of-the-art methods in terms of comparing to the SOTA, right? Text classification frameworks, right? Like Cybert and Albert and all of this. And I think Ines did a very good job because, the goal was not to beat the state of the art, but still Marta is really competitive in terms of does it classify the documents correctly, right? It was actually better than the state of the art we considered. But also, we used rational aware methods, and there Marta was clearly also better in terms of accuracy and F1 score. But in the end, the most important part was the explainability itself. Right. So for us, or at least for Armatrice, the important part was that the overlap between what a human would highlight in terms of, oh, this is the reason why we classify this instance as this class, and the highlight given by Marta is better than a typical attention mechanism or the state-of-the-art methods. So the overlap between those two was higher than the state-of-the-art. Okay, and I think I'm going a bit too slow, so let me introduce something new, right? Something that actually Ines will present at WWW in 1 month, in a few weeks, in Austin next month. So this is this time about the taxonomy, right? That's the latest thing we've been working on. The issue is as follows. We use a taxonomy for the different, fine-grained concepts for technology, but this is being expanded all the time, meaning that right now with the craziness about generative AI, for example, you can imagine all kinds of subcategory of generative AI being important, and they were not important when we started discussing the taxonomy 2 years ago, obviously, right? So the idea is you need to automatically maintain this taxonomy. And this is the same for a knowledge graph, right? And as you might know, this is a huge headache because the knowledge graph is always outdated, basically, right? So if you have new instances with new cool concepts coming up, you can perhaps detect those new, these new entities, right? But then if you want to classify them correctly in a taxonomy, which we do use for Armatrice, you need to put the new concept in the right place in the taxonomy. And that's basically this problem that we are working on with taxonomy completion, right? You have the current kind of taxonomy we are using with Armatrice, and suddenly let's imagine that unsupervised learning is becoming so big that you need a dedicated node for this, right? You've seen that there's a lot of papers / companies, more companies than papers. So in our case, you have a lot of companies doing unsupervised learning, or semi-supervised, whatever. Then you need to put this node in the right context in this taxonomy. And it's important, right? Because obviously that's the whole power of a taxonomy, is to have a hierarchy of super concepts, coarse-grained concepts, and fine-grained concepts. And this is very important for then, post hoc analysis, for aggregation of all those different concepts, for all kinds of statistics, right, that ARMA Suisse wants to do. So here comes TaxoComplete. The goal, as I told you, is to identify the position of your new node in the taxonomy. Given a bit of context, right? Typically, we have labels about the different concepts. And the contribution is this self-supervised taxonomy completion framework. Ines worked on this also, and I think she got great results, as I will try to explain in a few minutes. So there are two main components in this work. The first is this self-supervision step. I guess these days you will immediately understand how it works. We basically take the current taxonomy, we select a node, which we call query node. Here it's relational database, because we like databases in my group. And you generate training data from this query node by identifying neighbors in terms of the nodes in the taxonomy. So we actually take the child and the ancestors and the sibling and the distant nodes, right, which are basically in red here, and which are not those nodes I just mentioned, which are further in the graph. And the framework relies on two key innovations. First, we try to map the semantic distance that we are using in terms of cosine similarity to represent the different concepts. We match this to the distance that the different nodes have in the graph. Okay, what's the idea? The idea is as follows. We have embeddings for those concepts in terms of text, right? But we also have this graph or taxonomy structure, right? So both should be basically similar, right? In the sense that if two nodes are close in the graph, they also should be close in a semantic embedding kind of way. Okay, so we have this query encode semantic matching mechanism to encode pairs of nodes such that the semantic distance in the embeddings match to the graph distance in the taxonomy. Okay, so this is, by the way, illustrated here. You have the query nodes and an anchor node. You try to understand where, if they are kind of similar, right? So you represent both using some textual content and some large language model into embeddings. Then you can do cosine, but you have a specific loss which also use the graph distance between those two nodes to actually match them. Okay, that's the first part. So we want to take into consideration not only text distance, but graph taxonomic distance. The second part is a direction-aware propagation module. So we do this in an undirected way, right, for this matching, because it gives better results. But still, we have quite a bit of information also in terms of neighborhoods and also direction of the edges. So Ines added a propagation module to basically propagate information about the embeddings of one node to other nearby nodes, right? The idea is that neighborhoods should have the same, should have similar properties, right, in terms of the embedding space. And for this, we used basically this propagation framework of the features in terms of personalized page rank. And this is an ICLR paper, by the way, which is, I think, fairly well done. And the results, I think, are pretty outstanding. So we have much better performance, basically, than the state of the art. We are not the first one looking at this, but those two specific contributions made a difference, right? If we look at MR here, mean rank, lower is better. We are in red here. In that case, a bit similar. So we are basically, I would argue, twice better in terms of all kinds of metrics compared to the state of the art. Okay, so that's basically what I wanted to say today. In conclusion, two things. First, think about it, right? Monitoring is a key application, and I think we don't work enough on this in terms of research, right? It's a key application to all the big players, like any big company, and even the small ones, actually. Even we as researchers, when we want to monitor what other researchers are doing, I do this manually by going to conferences and reading papers in good conferences, but probably there must be better ways of doing this, right? Of monitoring what's happening in specific fields. So basically, my point is, monitoring is a super important application, but we have too much information today. And I think knowledge graphs, knowledge bases, taxonomies can help in terms of structuring the problem, getting additional information, right? Getting information from external knowledge bases or getting information from the structure of the graph or the taxonomy. But obviously, crowdsourcing and AI can help as well. And I guess I don't have to talk too much about this these days. That's a bit what I wanted to say. I wanted to add a bit of, software, hardware co-design, saying that all of this requires tons of computation, right? And CPUs are slower than slow these days. And that's what part of the group is doing also in Fribourg. Increasingly, we use all kinds of accelerators to do this fast. So we use not only GPUs, right, but we use like smart switches, smart SSDs, smart network cards to accelerate all those processings. We have a SIGMOD paper actually coming up this summer to explain how we can, accelerate all kinds of graph processing using all kinds of new hardware. Why? Because otherwise, basically, we cannot think Microsoft, right? We cannot basically do whatever I told you about on a very large graph for taxonomy. This is simply too big. Thank you so much for the attention. I think we have a bit of time for questions.
Thank you, Philippe. Thanks for the amazing talk about the work, the many nice work that you did on information monitoring. So we can now open for questions. So I think we have a few questions already from the audience. Lakshmi, if you want to ask the questions yourself, you can simply open your mic.
Hi, I'm Arun. So yeah, the first question was actually related to the beginning of the third part of the talk, which was about text classification. So I was just interested to know if we were using any evaluation techniques, but I think I got an answer to that talk, that question. The other thing is, I see here is that if there is, when you capture the rational awareness based on the human justification, how sure are we in terms of like its explainability itself?
I'm not sure I understood the question. Can you repeat quickly?
So when you actually use the rational awareness for your model, when you do the classification, you use the human justification as the key to use that, right? Like, so how sure are we is that the human justification is sufficient?
So how sure are we about the rationales given by the crowd workers?
Yeah, in terms of how it's explainable, in terms of using it.
Or in terms of how good it is in terms of explanation?
Yep.
That's a good question. So our customer was happy. So Amasis, for them, I think it's good enough, right, to give the sentence, which is, or the sentences, right, which is basically the most important in terms of the classification. The advantage is that it's text, right? So if you give basically a very small subset of the input text as a justification, I think this is this is a good human compatible, human understandable justification, simply because it's text, right? And we love text as humans. I don't know if Ines, you have a better answer.
Yeah, I think that was a great answer. Maybe what I can add is that through the crowdsourcing task, we iterate through it to make sure that what is provided by workers is actually aligned with what we expect. And the idea from the work is to basically map the rationale that is provided by the framework at the end with a rationale that is given by a human, and it's a good justification for the task.
Yeah, thank you.
Yeah, but thanks for the question. I think it's always a hard question, like, basically how to explain things. And I think very often managers are not super happy with explanations that we as engineers give, right? So I think it's an important question. Yeah.
Thanks, Aru. Shaheen, you want to ask? Oh, Shaheen just sent me a message that you cannot open the mic. I can read for you. So the question is, for calculating the graph level similarity, how do you ensure that the graph morphology is well preserved in the generated graph embedding?
So, oops. I think this is this, right? This is this. So basically, the loss minimizes the difference between the cosine of the embeddings based on text and this LQA, which is proportional to the graph distance. Ines, feel free to contradict me. So this is basically the loss function, like, which minimizes this.
I see. Unless Shaheen, you have more questions, we will go on. So maybe a question from me, connecting to what we were discussing, right? So Philippe, you mentioned that there might be a gap, right, between the explanations generated through the method designed by the engineer and the explanations that the users or managers would like to see. So how big so I'm just curious, right? Did you have any experience observing like how explanations generated are used by the people, the clients, and if you see any specific challenges over there?
That's a very good question. I meet Arma Swiss very regularly, so I'll make sure to ask them next time. Next time I meet them. So I think there are two things. The first is perhaps a bit sad, but that's reality. They might not look that much at the rationales, but they still want a method which is explainable. Why? Because they are in a specific domain, right? Again, it's like confederation, it's defense. So they want to be able to justify their methods and their actions if needs be, right? So very often, I think it's really like, it's simply a requirement. They will not use any methods if, they cannot have some explanation for the outcome. And then they do a lot of, post hoc analytics. They do a lot of looking back at cases and understand what went wrong, right? I think that's their culture. Like they look at incidents and they understand why it was a disaster, basically, right? Since they had an incident, right? And I think in that case, it's very important that if something went wrong in terms of, let's imagine, right, like this ARMA tweet system missing a very, very important event, they want to understand basically, why it missed the event. And in terms of classification, it's the same, right? If if they totally missed some text, some companies on the radar, they still want to understand why. And as you understand, this is a very complex question, right? And I don't think Marta, for example, is sufficient to understand why suddenly they are missing part of the classification results. But hopefully it can help in analyzing, inputs, outputs, and understand a bit better the situation.
Mhm. I see. Yeah, indeed. So the results generated from Marta is still mostly in the unstructured data format, right? So for example, the highlighted rationale here is still sentences. I was wondering if it makes sense to, convert this to something that might be, more structured and more queryable. So, whenever there is a need from the user to understand what is the causes, right, in the machine learning phase that makes the model miss certain event. If that would be useful, to have some sort of more structured representation of what the model has learned, right?
Yeah, probably agree. Probably it would be very useful in a more global context, right? To understand the system as a whole and not what happened to this specific classification kind of scenario, right?
I see.
Yeah, we'll ask them about it. I think they probably would love it. Right?
Yeah. So one idea that, well, since there's no more questions from the audience, I will just keep talking. So in case there's any questions from the audience, please just speak out. So to follow again what we were discussing, right? I was wondering if it's possible to do some proactive discovery of potential wrong decisions made by the machine learning model or systems by for example, integrating some sort of human knowledge beforehand to check maybe to identify certain missing knowledge in the model.
Oh, you froze.
If that's if that sounds so we were discussing about when if the users see, right, there's something going wrong, right, maybe they would now suddenly have the need to feel the need to go back to the into the process where this decision is made, right, and then try to identify what's going wrong there. And essentially it requires some sort of checking what the model is doing, looking at the rationale, and also mapping that to requirements, right, certain requirements of what model should be doing. And I was wondering if it makes sense to compare this already, what the knowledge that the model has learned with the requirement somehow, right, before it's deployed, so that can.
Yeah. No, again, very good points. I think it's basically human in the loop, right? It's really making sure that machines and humans are aligned. By the way, the big tech companies, they do it, right? Also in terms of continuous monitoring, right? So a friend of mine did this at Meta, for example. He created this continuous loop where important models at Meta, they are always compared to human outputs. And there is this continuous loop, the model is getting off compared to humans, and we have to do something. So I think for some models, this is already a prerequisite. Important models, right? It should probably happen also in the development of the model, but also in the deployment of any models. But guess what? All of this is very, as you can imagine, it's labor intensive, right? So if you can automate all of this, sure. if you need real humans to always give feedback, then only the big companies can do it, I suppose.
Indeed, it requires additional budget for that. We have.
Yeah, we have a question. I can read it actually. How were you able to verify that TaxoComplete is able to stay up to date Actually, we don't do it, right? We, as always, I guess in research, we take only part of the problem. So the problem we tackled in this particular last contribution is given a new node, where to place it. So we didn't talk about how to get this new node, but we could imagine, be careful, I'm always optimistic, but we could imagine that this is not too difficult. You would basically have to analyze, do entity recognition on all the new text coming in and identify that you have new entities which are becoming so important. And then you would try to place those entities. You would find those entities in a knowledge base like Wikidata or somewhere, or a definition in the text. And then you would use basically our technique, right? So once you have this new node, make sure to automatically put it correctly in the taxonomy. So we did not cover this particular part of, is it up to date or not?
Yeah, thank you.
No problem.
And we also have another question from Shaheen. So in the case of Mata, does symbolic learning make sense? I guess Shaheen was trying to say, is there some way of integrate symbolic way of doing machine learning, right? Into or with Mata somehow? If Shaheen,
Good question. Ines, get ready to answer. But but in the meantime, I think it's a Bayesian framework. So then I know if Bayesian is structured enough to be symbolic or not. What's your big J? Is Bayesian symbolic or it's not symbolic?
I think it depends. It can handle symbolic way of learning. I think it depends, right? So it all depends if the input is structured data or not. Most of the time, I mean, in this case, we didn't really use any structured input, but there are Bayesian method that is created for handling the structured data, considering also, for example, the logic constraint, right? There is this what's the method? Bayesian logic model, something like that, just like Markov logic model, right? So there are also these methods.
Yeah. Ines, any idea how symbolic could help Marta?
I guess in the process of inferring of deriving the information, of deriving the rationale, we can think of another way of integrating symbolic learning into Marta, such that it can explain not only why it provided this output, but what was the process that led to it, what is the learning process that led to this particular result. So one can think of integrating symbolic learning into Marta if this could be interesting.
Great, thanks. Looking at the clock, I think we are 6 minutes more than we asked from you, Philippe. Thanks.
Actually, I have a big meeting coming up, so yeah, I think unfortunately we should end this session. Happy to discuss offline. Obviously, if you're interested in extending this, and don't hesitate to reach out to either Jay or Ines, who know a lot about all of this.
Thanks once again, Philippe. It's a great pleasure to have you here. And thanks everyone for joining the talk. With this talk, we finalize this edition of TAF. We've had a great journey with all these inspiring talks, and we will follow up with the next edition on a related theme. Please stay tuned. Thank you.
Thanks a lot.
Thanks. Bye-bye.
Bye.